So in the last video we looked at concentration time graphs. This time we're going to look at rate concentration graphs. And you need to be able to sketch one or to recognize them from zero, first and second order reactants. So I'm going to start off by drawing a rate concentration graph for a zero order. This is rate concentration. I'm going to put rate on my y-axis and concentration on my x, and let's just say that we're looking at the concentration of reactant A. Because it's zero order, I know that regardless of the concentration of A, the rate is going to remain exactly the same. So even as I increase the concentration of A, the rate must remain constant. Because I've got rate here on the y-axis, what I need is for that y value not to change. So I'm going to need to draw a straight line coming out of that y-axis. And what this shows me is that as the concentration increases, as I move along the x-axis, that rate stays exactly the same, which is what I would expect for a zero order reactant. The concentration should have no effect on the rate. If I want to work out K, I know that rate equals K. I know that rate equals K times A to the power of 0. Anything to the power of 0 is 1, so I can change that to rate equals K. And if I want to calculate rate on this particular graph, no tangents needed, no gradients needed, I just look at the y-intercept. If I want to see the rate, I just read that straight off the y-axis. So I can say that rate is the y-intercept, wherever the graph cuts the y-axis, and rate equals K. The next one we're going to have a look at is what a first order would look like. So again, I'm going to have concentration, I'm going to have rate, and I'm going to have concentration. And with a first order, I know that if I increase the concentration, I'm also going to increase the rate. And I know that they're going to be directly proportional. And by that I mean if I double the concentration, I double the rate. And if I triple the concentration, I triple the rate. So what I'm going to have, because it's directly proportional, as well as showing that increase in concentration and rate, I'm going to get myself a dead straight line. It's directly proportional. I double the concentration, I double the rate, I 10 times the concentration, I get 10 times the rate. I get this dead straight line. And this is what I've got for a first order reaction. Again, if I want to calculate K, that's going to say that this reactant is called B. Rate equals K times B, and this time it's first order. So if I want to rearrange for K, I get K equals rate over the concentration of B. To work this out, all right, I can just read it from my graph. Just say I go to this point here, let's say the rate is 10. All right, I can read that off my graph, that's 10. And then I can come across here to my graph, work my way down, and read off whatever the concentration is. Let's just say in this case it's 20, and that allows me to solve for K. Now what you'll often see is that they'll say that K is the gradient of the line, okay? But if you look at what we've just done, all right, I read this value off as 10 because rate is on the y-axis. Let's say that this is 0. That there represents the change in y. I'm going from 0 to 10. That value 10 represents the change in y. So by just reading the value for rate off the y-axis, I've got the change in the y-axis. And then by reading the value for concentration off the x-axis, I have got the change in the x-axis. So I do have change in y over change in x. So by doing this, I can say that I'm calculating the gradient of that line, and I'm also calculating K. So that's going to be K for your first order reactant. And then for a second order reactant, and this is slightly longer, all right, what I would expect a second order reactant graph to look like, let's say C is my second order reactant, what I would expect it to look like is I know that as my concentration of C increases, my rate increases. And I'm not going to have a straight line because the concentration of C is going to have a greater effect on that rate. So what I'm going to end up with is a curve that looks something like this. So it gets even steeper and steeper. And if you were asked to sketch a second order graph, that is what you would sketch, okay? However, unlike with 0 and first, I know for sure that that's first because it's a dead straight line through the origin. And I know for sure that this one is 0 because it's dead straight coming out of the y-intercept. But with this one here, this second order, if I had a third order, it would, which we don't study at A level, but if I did have a third order, it would look quite similar to this. It would be a curve and it would rise up steeply. And again, if I had a second and a third order side by side, the steeper one would be the third order. And if I had them side by side, I'd be able to compare and make that judgment. But just as a standalone graph, seeing that, I can't say for sure it's definitely second order, even though it's the shape that I might expect it to be. So to confirm fully that it is a second order reactant, what I would have to do is I'd have to take the concentrations of C that they gave me and I'd have to square them all. Because when we're looking at second order, it's proportional to the concentration squared. So I'd have to square each of those concentrations. I would also have the rate, and then I'd have to plot a new graph. And instead of rate versus concentration, I would end up with rate versus concentration squared. So I'd have rate still on my y-axis and I'd have C squared on my x-axis. And if it was truly a second order, once you've squared all your concentrations and plot that against rate, if it's a second order graph, I should get a dead straight line because the rate is proportional to the concentration squared. And if I get that dead straight line, then I know for sure that I definitely have a second order reactant. Without going through that step, I can't know for sure that it's first order. So it's similar to the previous video when we said this is the shape you'd expect a first order graph to be, but you need to use half-life to show that it definitely was. With rate concentration graphs with second order, this is the shape that you'd expect it to be, but to confirm that it definitely is, you'd replot rate versus concentration squared, and that straight line confirms that it is definitely a second order graph. And once you've got your straight line graph of rate versus A squared, what you can do then, if I write my rate equation, rate equals K times the concentration of C squared. If I rearrange this, I get K equals rate over concentration squared, and it becomes exactly the same as what we just did. So if I want to read off the rate, there's my value there for rate. Let's just say that the rate is 5. And then I come across, I come down, and I can find my answer for C squared. Let's just say the concentration of C squared there is 10. And again, this is the same as getting the gradient of the line by using this value, by reading rate off the y-axis, I have got the change in y, and by reading concentration squared off the x-axis, what I've actually done is get the change in x. So by doing this, I am getting the gradient of that line, and that's going to equal to K for a second order reaction. The main thing with these graphs is that you look at the axes before you dive into the questions. We've looked at two different types of graph. We've looked at concentration time, and we've looked at rate concentration. I've just got a little summary here where all the graphs are side by side. Flare. All right. When you had your concentration time graphs, you have that shape for 0, that shape for first. Again, you don't need to be able to draw a second on concentration time. And then here's your rate concentration, so very different shapes. So you need to look at the axes, see what type of graph you have before you dive in and predict the order. You also need to know how to calculate rate, and you need to know how to calculate K, regardless of which graph you are given, which is also summarized for you here. Once you're feeling comfortable with that, again, there are tons of practice questions. So I would advise, once you've got it finished, to go down to the exam questions and to do all of the exam questions. Don't avoid the ones that tell you to draw a graph. Actually do it. Draw the graph, draw the tangent, make sure you're comfortable with those skills.